Well, today I'll be teaching our equations of motion, which we all know that there are three. This A now stands for average velocity, which is equals to final velocity, which will represent with the V, and then the initial velocity, which will represent with U. So we'll say V plus U all over 2 equals to average velocity. So from this, we'll say this average velocity now at distance S. Distance S will introduce a term to it, which is going to be T, and we'll have V plus U bracket T, which T is the time taken to cover distance S. So from this very equation, I will want to go to another one, which is acceleration. So we'll say acceleration, which will represent with A. So we'll say A is equals to what? Final velocity V minus initial velocity U all over what? T. So I will try to see I make V the subject of the formula from this equation. So let me just cross multiply. So if I cross multiply, I will have AT equals to, let's just say AT equals to what? AT equals to V minus U. So trying to make V the subject of the formula, I will try to eliminate this U. Okay, since I have a minus here, I'll plus U here, and then I'll plus U on both sides. So let's just see. So minus U plus U, we'll say it is equals to 0. So I'm left with V is equals to U plus AT, which is equation 1, and equals to, like, this is the equation 1, the first equation of motion. So from this first equation of motion, I'll be moving to get the second equation of motion. So second equation of motion, second equation of motion. So now I know the value of my V to be U plus AT. So I'll go back to that same equation. S is equals to what? V plus U all over 2. Then T. But this time around, I want to use the value of V for V. So I will say S is equals to what? Substituting, I will say equals to U plus AT plus what? U all over what? 2. Then I will say times T outside. So trying to bring the legs together, I will just say U plus U equals to 2U plus AT all over 2, which is the T outside. So we'll have it that now 2U plus AT times T outside the bracket all over 2. So what we'll do now is I will try to open the bracket and bring the T inside. So I will say T times U2. So I will say 2UT. So plus what? AT squared. AT times T. I will just have it that it is AT squared all over 2. Then I will say equals to S. So since we know now that S is equals to 2UT plus AT squared all over 2. So this 2 here divides both. So I will just cancel this. So I was just, this 2 now is now dividing only AT squared. So I will say S is equals to what? UT plus half AT squared, which is equals to equation 2, the second equation of motion. So now I will want to go ahead and find the third equation of motion. Third equation of motion. Okay, so let's go back to acceleration. A equals to what? v minus u all over t. So knowing that acceleration is equals to v minus u all over t, we'll just go ahead and say, let's make t the subject of the formula. Okay, if I say a is divided by 1, yeah, we all know that. I guess we know that. So let's just say, if you don't know, you should know that it is literally that a is dividing something and it's always 1. If I thought there's nothing there, we just don't write it. So now we'll say that cross multiplying this equation, we'll have at is equals to what? V minus u. So having it like that, I want to make t the subject of formula. I'll divide both sides by a. So I will say what? A cancel a. So we'll say t is equals to what? V minus u all over a. So that's the value of t. So now I'm going back to that same equation we had, which is x, average velocity at distance s. So it's going to be what? Initial velocity plus final velocity v plus initial velocity u. Okay, so all over what? 2 at distance t. We know that already. So the only thing we'll do now, we'll substitute the value of t with v minus u all over a. So I will say s is equals to what? V plus u all over 2. Then I will introduce that v minus u all over a. Then we all know that there's a times here. Then what I will do next, I will try to expand or open the bracket. So I will say s is equals to what? V times v is equals to v squared. Then plus u minus u plus u times minus u. We all know that minus is superior, so we'll say minus u squared. So all over what? 2 times a, which is equals to 2a. If I cross multiply again, I will be left with, I'll have 2as equals to what? V squared minus u squared. I'm trying to make v squared the subject of the formula right now. So what I'll do next, I'll just try to see that I eliminate the u squared, the minus u squared. So I'll just say plus u squared on both sides. Okay, plus u squared. So I'll say this u squared minus u squared plus u squared is equals to 0. Then I'm left with v squared is equals to u squared plus 2as as my third equation of motion. So from these equations, we can see that we found the first equation of motion to be what? V is equals to u plus at. Then the second equation of motion, we said it is s is equals to what? S is equals to ut plus half at squared. Then the third equation of motion, we found the third equation of motion to be what? V squared is equals to u squared plus 2as, which a is the acceleration and s is the distance. So we look at this to be the 1, then this equation 2, then this equation 3. Very important equation when it comes to solving problems associated with motions. So the only thing now that I want to let you know is, sometimes you can see that we have the positive sign to be minus. The positive signs are minus because of only when we have a uniform deceleration, then we say the sign becomes minus. But on a normal ground, they are positive. So these are the 3 basic equations of motion. And I would like you to subscribe, and in our next class, I will be teaching you how to